Okay, for those who are unable to get on Teams for whatever reason, I want to make sure that I have a video that I share with you, that I share with the group online today. So the first question on the PowerPoint was, in which number is the value of the digit 2 10 times the value of the digit 2 in 58,720? So we know when we're doing times 10 anything, when we're comparing numbers, we have to do a place value chart. As you go up to the place value chart, as you can see here on my board, you're adding a 0. So each place, as you're moving along, is 10 times more than the previous place. Oops, this is too close. Let me move this over. Move my 10,000 over. And I do my wiggly line so it's never mistaken to be a 1 when I'm showing my work. Okay, so the number here, it goes on the place value chart, 58,720. And it's talking about the 2, because it says the 2, the digit 2 and 10 times the value of the digit 2. So we are identifying the number 2 here. And then we're going to do times 1. And every time we hop over and the place value increases, we add a 0 here. So every hop, you add a 0. And when we get to 10, because it says 10 times the value, so when we get to that, that's when we are going to stop. So we're going to go to that. When we start here, we hop over 1 spot. And we add a 0 here. So this place, the 7, is 10 times more than the place value held by the 2 here. So we're looking for an answer where 2 is in the hundreds place. Okay? We're looking for a 2 that is 10 times more than 2 that's in the tens place. So we're looking for a number where 2 is in the hundreds place. So let's look at our choices. And so we clearly see that B, 87,205, is in the hundreds spot. So that will be our answer. Okay? Our next one. In the number 45,697, which digit is in the place that is 10 times greater than the place held by the 9? So again, we have our place value chart. And we're going to put our number on our place value chart. Let me do my wiggly lines, so it's never mistaken to be a 1. So we have 45,697. They're talking about the 9. And we're looking for the digit that is in the place that's 10 times greater than the 9. So we're going to do our automatic times 1. And each time we hop over, we add a 0. So I start here, I hop over, I add my 0. This is 10 times. So which number holds that place? It will be B, the 6. Because the 9 is here, we only hop 1 place to show 10 times more. So the 6 is in a place value that is 10 times more than the 9. Okay? Now we're going to, it says, which displays 3 factors of 18? Well, when we do factors, we do our T-chart. And so if our number is 9 or larger, we stop at 9. So I have my T-chart with my 18. And I'm a number to 9. Okay, 1 times what gives me 18? 18. 2 times what? Let's see. 2, 4, 6, 8, 10, 12, 14, 16, 18. So that gave me 9. 2 times 9 is 18. What about 3? 3, 6, 9, 12, 15, 18. That's 6. What about 4? 4, 8, 12, 16, 20. I didn't say 18. 5, 10, 15, 20. I didn't say 18. Now, 3 times 6 gives you 18, so you know 6 times 3 gives you 18. Okay, let's do 7. 7, 14, 21. I didn't say 18. 8, 16, 24. I didn't say 18. 9, 18. That's 2. So let me write my factors of 2. So I'm going to do my parentheses here and look very close, because a lot of kids just try and just write the numbers, but it's a purpose to the reason why I do it as pairs. So we're going to take the first 2, 1 and 18. So that's beginning and the end. The next line is our 2 and the 9. Excuse me. 2 and 9. The next one, 3 and 6. The next one, 6 and 3, we already have it. The next one, 9 and 2, we already have it. So let's look at what we have. Let's look at our choices here. Well, 0 is definitely not on our T-chart, so we know it's not A. 1, 18, 36. 36 is not on ours, so we know that's not it. 2, 3, and 6. Let's see. We have 2, 3, and 6. I think we have a winner. Now let's look at D. Make sure that it's not D. 2, 3, and 4. 2, 3, and we don't have 4. So C is our answer. That's why it's just so important to list them out again, okay? And not just look. A lot of us, a lot of times we don't take the time to look to make sure. We just look at it and guess at it. And sometimes we can make a mistake going too quickly. So this says, which displays all of the factors of 24. Okay? So again, I'm going to my T-chart. The number is over 9, so I still stop at 9. One times what gives me 24? 24. What about 2? 2, 4, 6, 8, 10, 12. What about 3? 3, 6, 9, 12, 15, 18, 21, 24. That's 8 times. What about 4? 4, 8, 12, 16, 20, 24. That's 6. What about 5? 5, 10, 15, 20, 25. I never say 24. Well, 4 times 6 is 24, so 6 times 4 is 24. Let's do 7s. 7, 14, 21, 28. Nope, I don't say 24. 8. 8, 16, 24. 3. Or I could have saw that the reciprocal was up here. 9, 18, 27. So let's look at our factors again. And we start the first 2, the beginning and the end. So 1 and 24. 2 and 12. 3 and 8. 4 and 6. Okay, so which one is definitely not A? A was actually multiples of 24. B, 5 is not. That was not one of our factors. C, let's see, we have 1, 2, 3, 4, 6, 8, 12, 24. Looks like C again. So why not D? Take a moment. Why not D? Because of 10. 10 is not a factor of 24. 10 times nothing gives us 24. Okay. Now we're going to, we actually didn't do that one in class. Let's do this one. This one says, teachers are taking 257 students on a field trip. Almost all students are riding buses, with a few riding in a van. If the teachers equally place the students onto 6 buses, How many students will be left to ride in the van? Okay. So I want you to determine what operation are we doing? Is it addition, subtraction, multiplication, and division? And how do you know? So I would say it gives me the total, the 257. It equally places them. So that's division. Division gives you the total. That's the number that's in the box. That's the dividend. Okay? Equally, when you multiply, you're not doing equal amounts. You're just multiplying and getting a larger number. So this is a division problem. Okay? And plus it says how many students will be left. You don't have anything left or remaining when you multiply. Okay? So let's come and do the work. In the box, we have our 257. And it's 6 buses. So I'm going to come up here and do my multiples of 6. As I said online today, it is crucial that students know their multiplication facts so they're able to write them just as fast as I'm writing these here. So that way you're not spending 2 and 3 minutes just writing down the facts. Okay, that's something we should know automatically. It should be a tool that helps us and not a hindrance at this point. Okay, so the very first number in the box, you say to yourself, is this 2 the same or larger than this 6? If it is not, it's an automatic 0. So it has to be automatic 0 because it's 2 isn't big enough. It's not the same as 6 and it's not larger than 6. So the 2 goes over and it helps itself with the 5. So now our number is 25. So our goal is to find a multiple that is as close to 25 without going over. So we're going to stop here. And how many did we go down? 1, 2, 3, 4. And we have 24 here and 25. If they're not the same number, that means we're going to subtract. So we are going to subtract. And we have 1. This one here goes to the next number in the box. So now instead of 7 here, we have 17. Now my job is to get as close to 17 without going over. So I can stop on 12. How many multiples did we go down? 1, 2. Is this 12 and 17 the same number? No, they're different, so that means we have to subtract them. Put 12 in your head and count up to 17. 12, 13, 14, 15, 16, 17. Remainder 5. So let's see what the question asks us. Let me read that last question because this is what a lot of us are failing to do on exams and tests and homework, and they're just putting the answer. Read the last question. Make sure your answer makes sense with what the question is asking you. How many students will be left to ride in the van? Well, let's dissect this. The 42 here is the quotient. It's the answer to the division problem, but that's how many students are on each bus. There are 6 buses, and so there are 42 children on each bus. 5 students remain or are left to ride in the van. So our answer will be 5. Okay? So now we're going to do one more, and this is about Sage. Let's see what Sage is doing. Sage must be a baker. Okay? Sage bakes 123 cupcakes. If she equally shares the cupcakes into 7 containers, how many containers will be completely filled? Okay, so what operation are we doing here? I would say we're doing division because it gave us the total amount of cupcakes. 123, that was the total amount. I see equally shares. Another clue that is division. How many are completely filled? That could even be 1. Okay. So it's suggesting that you possibly could have a remainder. We'll see. So we'll put 123 inside And it's 7 cupcakes can go in a container. So now I'm going to do my multiples of 7. And parents, it should not take kids over 1 minute. Normally, I would say 30 to 45 seconds to write their multiples. Otherwise, they don't know them by heart, and it's more of a hindrance to them than it is helping them. That's why it's so important. We're going to continue to push until all the students know them. Okay? Remember with division, the first number here is a 1. This number here has to be the same or larger than the divisor that's on the outside. It is not. So therefore, we're going to do an automatic 0. We're going to move this over, and now we have 12. Okay, now we cannot pass 12. We need to get as close as possible. The closest we can get is the 7. Okay, so we went down 1. Who was at the first one? So the 12 and 7 are different numbers, so we have to subtract them. 7 goes in your head, and you count up till you get to 12. So 7 in your head, 8, 9, 10, 11, 12. That's 5. This 5 here goes up here with this 3. Now it's 53. Now looking at our multiples, we have to get as close to 53 without going over. And that will put us at 49. Well, how many did we go down? 1, 2, 3, 4, 5, 6, 7. So 7 goes up top. Is 53 and 49 the same number? Of course not. So we have to subtract because why? They're different. 49 goes in your head. We're going to count up to 53. So 49, 50, 51, 52, 53. That gives us 4. So we have 17 remainder 4. Now let's go back and reread that last sentence to see what is the most reasonable answer based on what it's asking. How many containers will be completely filled? Looking at my problem, 17 will be completely filled, and then it'll be 1 container with only 4 in there. So our answer is C, 17. Okay, so if you have not done so yet, please go to quizzes, and the code is here. Is also on my Canvas page. And it's a 5-problem, quiz, just a checkpoint of review, dealing with some of the things that we learned on today. And let's see how you do on them. See you later.